Hi everyone and welcome back to Fundamentals of Engineering with Farhad, Mechanics of Materials. We have solved this example with the help of a load distribution, moment equation, moment area method, and this time we want to solve it with the combined method to get the delta maximum for a two simple support beam. So Mechanics of Materials, solution 4. Maximum deflection in beam. So solution 1 was determination of elastic curve or delta function from load distribution, which is W. Solution 2 is determination of elastic curve calculating delta. This part, it just means y function, y based off x. Y, we are looking for y, and finally delta max. And then in the third solution with the help of moment area method, and in our last solution we're focusing on combined method, which is I like this method. I think it's the easiest one, so but it's up to you to use each of the previous methods. So solution 4, that's why I just provide you with the different approach for a single problem to make a comparison between them and see which one you like. So in solution 4, if we just remove the half of the beam and use a sliding method at its center that allows the beam to dive down to the delta maximum, and definitely we know R sub A, so each support handles a half of the load, which is WL over 2, and it just says if we have a sliding support, if we just remove the support at A, because a sliding support has a 2 degree of statical indeterminacy, it prevents moving in X direction, it prevents a moment rotation, but it just lets you move upward and downward. Due to our loading, it's downward. And then if we just release support A and add it to support at the center, which is sliding support, we have like a fixed support at A, at C. 1 degree of indeterminacy added to center, and A is released, so we have like a cantilever beam. So if we release support at A, but we use RA there, then replace a sliding support with fixed support. It seems like support at A added to a sliding support to create a fixed support at A. Now we have a cantilever beam with two kind of loading. That's why we call it a combined method. So we have replaced our sliding support at the center by adding A support at A to the center and release A. Now we have cantilever beam. So now we have a cantilever beam with the concentrated load of R sub AWL over 2 at its free end A, and the distributed load of W along entire beam. So that's why we call it a combined support. Now we have a two cantilever beam, one with a distributed load of W plus the other with just a downward W, a downward the distributed load of W in a cantilever beam with the length of L over 2 plus a cantilever beam with an upward load of WL over 2. And now if we calculate the delta of each of these beam and add them together, we can easily calculate delta maximum at the center. So we have like the delta 1 due to distributed downward distributed load, we get the delta 1 and add it to a delta 2 due to a concentrate upward concentrated load of W over WL over 2. And we do know that the delta, we already calculate the delta due to a distributed load on a cantilever beam with different approaches. I will provide you the link of this video on the comments. So that's a downward W L squared and our length is L over 2. That's a half L to, my bad, L to the fourth. So our length is L over 2 up to the center from A. That's L over 2 to the fourth over 8 EI. That's our delta 1. Mhm. And also we have like calculated delta for a cantilever beam with concentrated load. So that's PL cubed over 3EI in denominator. Replace our P with R sub A, which is WL over 2, and it just gives us a P is WL over 2 and length by L over 2, then cube over 3EI. If we add these together, a downward movement due to distributed load of W and an upward deflection due to concentrated RA at free end A. So can, uh, take out the constant of WL to the force over EI, we can have a negative 1 over 8 times 16 for the first part plus a, my bad, this is positive. The other half is a positive because it's upward 1 over 16, 1 over 16 times 1 over 16 times 3 WL to the force over EI. If you add these two up together, it just gives you a negative 8 minus 3, which this part is a positive. Then a denominator 8 times 16 times 3, 8 times 3 is 24 times 16. 24 times 16 is 48 times 8. 48 times 8 is 96 times 4. And it makes us like 4 times 6, 4 times 9, 384. WL to the 4 over EI. So it just gives us a negative, which says the downward is uh, dominant, 5WL to the fourth over 384 EI. And that's intuitively correct because we do know due to a downward uh, distributed load all over the entire span of a two simple support beam, deflection is definitely downward. So again, that's what I'm telling. If we have intuition of delta maximum is not upward, so that's why we get delta maximum like 5 times WL to the fourth over 384, this time with the combined method. Now let's move to our original beam, and this time for calculation of delta. So we can have like again these two concentrated beam, two simple supported beam with a distributed load of W. We just uh, change to two of this beam for calculation of theta and delta, and then you can easily see we can have like again two different deflection, two different theta, theta 1 plus theta 2 for calculation of theta at A. So in such case, we have like theta 1 is equal to WL cubed over 6EI, and that's negative due to counterclockwise rotation, theta 1, but replace L by L over 2, plus the other one, theta 2 is a positive clockwise, that's P L squared over 2EI, and replace P and L, L by L over 2, and P by W L over 2, and add them up together. But please be careful when you are using combined method. You have a good sense of the rotation and deflection in terms of their uh, working with the negative and positive. Uh, that's not hard, but you have to be consistent with the direction. So theta 1 is a negative WL over 2 cubed over 6 EI plus theta 2 is this one. And if you add them up together, you can take out WL cubed over EI and you will have a negative 1 over 6 times 8 for theta 1 and 1 over 8 times 2 for the other part. Mhm. And if you add them up together, you will reach to 3 minus 1 times 6 times over 6 times 8 WL cubed over EI, and you will get WL cubed over 24 EI. And so we can easily see in the combined method, we can get the delta maximum calculation and also a, delta maximum calculation and also a, let me move back to this part. So we can have like 6 times 8 and 2 times 4 times 2. 2 times 4 times 2. That's correct. Yep, 8 times 2, 6 times 8. My bad. So we can easily see with the combined method, we can have easily calculate the delta maximum and also the effect of rotation at A and B. Delta max is 5L to the 4 over 384 and downward, and theta A is equal to theta B is WL cubed over 24 EI. Thank you. I'll see you in next videos.